Hello everybody. In this lesson we will talk about power. So first, it's probably a good idea to look at the translation of power. If we have a look here, we can see that the translations are quite broad, so it can be Kraft, Leistung, Macht, Energie, Gewalt, Stärke. And in physics, power is clearly defined, and you can see it here. It is the so-called Leistung. So let's come straight to the definition of power. The new thing, if we look at power, is the time. If you do a work in a very small amount of time, you have a big power, and your power is small if you need a long time for the same work. Hence, the definition is the work done divided by the time needed. As a formula, power is abbreviated with the capital letter P, and it is work divided over time. Instead of work, of course, you can also take the change of energy, which is the same. What is the SI unit of power? So the work is given in joules and the time is given in seconds, and 1 joule over second is called watt, abbreviated with the capital letter W. So make sure not to confuse the unit of watts, which is here, with the symbol for work, which is a W as well. However, this watt is not always used. There's a very famous example. If you look at cars, there they use the so-called horsepower. So here we see an example of some car, and actually you're supposed to give the power in watts, or here it is in kilowatts. So this car has 88 kilowatts, which corresponds to 120 horsepower. This one, 290 Newton meters, is the so-called torque. We will not look at that for the moment. So what is 1 horsepower? One horsepower. This corresponds to 746 watts, or rather, usually we write 1 horsepower equals 0.746 kilowatts. Since usually, if you look at car, it's given in kilowatts or in horsepower, so it's easier to memorize or use this one. So let's do an example. "88 kilowatts, that was the power of this car, and we can convert this to horsepower. So we have to say it is 1 horsepower over 0.746 kilowatts, because this is actually just the factor of 1, because this and this is equal. Then the kilowatt drops and we get the result in horsepower. You can put this to your calculator and you get some rough, not quite. I just wanted to write PS, since this is the unit used in German, Pferdestärke, but we stick to the English term, so let's make this horsepower. Maybe you would like to know what your power is. An easy experiment to find out is climbing the stairs. So let's assume you have a mass of 85 kilogram and you just go one level higher. So the height, at least if you do that at KME, is 3.4 meters. So at home you have probably a little bit less. And the time could be, let's assume here, 3.8 seconds. So the power that we have is work over time, and the work we do is we lift our body. So it is the mass times g times the height over delta t. So let's put in the numbers. 85 kilograms, 9.81 meter per second squared, 3.4 meters, and 3.8 seconds. So just for fun, we can have a look at the units. Kilograms times meter per second square is a Newton. Newton times meter is joule, and joule per second is watt. So we get something in watts, and if you calculate this, you get 746 watts. We see, if we compare to the horsepower, that this guy, concerning the power, is a horse. Maybe you have encountered this name watt earlier. And this watt was chosen due to Mr. James Watt. He was the constructor of the first real working steam engine, and these steam engine, they replaced horses. And of course, they wanted to give for these machines a number how many horses you can replace, and therefore this number is rather low. And of course, this horse has to do this or maintain this power over a couple of hours. And I would like to see you climbing the stairs at this speed for 6 hours, so probably you can't do that. So it's a good idea to have a look at some objects of daily life and the power rating of these objects. So we have seen a car which typically has somewhere about 50 to 200 kilowatts, which is nowadays some average value. What you also might have noticed is the saying on a light bulb. There it says maybe 60 watts if you have an old-fashioned one, or if you hopefully have a newer one with LED technique, this has dropped to typical value of 5 watts. Then an airplane has some 120 megawatts, so that's some Airbus A300 something I have been looking So we can see compared to a car, it is some 1,000 cars. Next thing is nuclear power plant. For example, Gösgen, which has an electric power of roughly 1 gigawatt, which is 1,000 megawatts. Now we come to the biggest machine that mankind has constructed up to now, and it is this Saturn V rocket that was going to the moon, and this had a power at lift off of 87 gigawatts. So that's quite something, and they have burned 14 tons of fuel every second to reach that, so that's really quite impressive. And of course, much more power, our sun, which has a value of 4 times 10 to the power of 26 watts. Let's go back to this energy saving light bulbs. So we have seen that the new technique can drop the power of a light bulb from 60 to roughly 5 watts. So we can say we roughly gain some 50 watts. So we could make a very simple calculation and say every person in Switzerland is replacing an old-fashioned by a modern LED bulb. Of course, it's not going to burn 24 hours per day, but as an assumption, we can just have a look what that tells us. So we have some 8 million people, so the total power is 8 million, roughly, times 50 watts that we could save, which amounts to 400 megawatts. So why did I do this calculation? We have seen that Gösgen, for example, produces 1 gigawatt, but there are older nuclear power plants in Switzerland like Mühleberg or Betznau, and these have a power rating of roughly 300 and something megawatts. So therefore, if we can save 50 watts each one of us, we can just get rid of one of the nuclear power plants. On the other hand, if you use this power all day long, so maybe you have a router in your house or some TV that is running all day, then you could easily use the power or need the power that a nuclear power plant produces. We can see that even small amounts of power changes can have a big effect on the total consumption.